Hello and welcome to the section 3.2 lecture. Today we're going to talk about adding numbers, adding rational numbers, I should say. In the last section we looked at what a rational number was. It really comes down to any fraction and then any decimal that we called terminating or repeating. Those are rational numbers, and we're going to look at how to add those today. And so if you remember back in Module 1 days, when we were talking about adding and subtracting whole numbers or integers, we had 1.1 that was adding integers with the same sign, and then 1.2 that was adding with different signs. We're combining that today, and we're going to talk about rational numbers adding with the same sign and different signs with some other things kind of sprinkled in. So we've got a lot to do today. Let's go ahead and get started. For adding with the same sign, the same rules of addition apply. I want to add the two numbers and keep the sign. Okay. The tricky part comes when we start adding the numbers. Okay, and how we do that. So this one says that Malachi hikes for 2.5 miles, stops for lunch, then he hikes for 1.5 more miles. How many miles did he hike altogether? So we're going to start at 2.5 and we're going to add 1.5. How you do that's up to you. I would recommend moving 0.5 and then moving 1. The 0.5 brings me from 2.5 to 3. The 1 brings me from 3 to 4. Okay, so overall he hiked 4 miles. And it says that we're moving right because the second add-end is positive. And that's actually going to take me right to my code word for the day is going to be addend. Okay. And this is going to be my code word. The word addend is the term that we use as a part of an addition problem. If you remember the answer to an addition problem, if I have an addition problem here, the answer is called the sum. And the things that are being added together are called addends. Okay, so that's just giving you a little definition of our code word today. The second example here says that Kyle pours out 3/4 of a liter of liquid from a beaker, then he pours out another half a liter. What's he going to end up at? So here they give us a number line that's broken into fourths, which they did that because the problem dealt with fourths. That was the lowest, the smallest unit of measurement that they had. Okay. It says use negative numbers to represent the amount of change each time Kyle pours liquid from the beaker. Okay. So we have negative 3/4 plus negative 1/2. I'm going to start at negative 3/4 and I'm going to move left because my second addend is negative. Okay, I'm going to move left 1/2, which is 1 2/4. Okay, so it's telling us overall he's removed 1 1/4 liters from the beaker. So now I want to explain how to determine whether to move left or right on the number line when adding rational numbers. It's just the same as when we added integers. I'm going to move right if the second addend is positive, and I'm going to move left if the second addend is negative. Okay. So let's look at that in practice. If I have 3 plus 1.5, I'm going to start at 3. Personally, I'm going to move 1, and then I'm going to move 1/2. Okay, bringing me to 4.5. Now, you could move 1/2 and then 1 if you wanted to. It's totally up to you. And for me, it's totally based on the problem. What seems easier to me. I like dealing with whole numbers, so I'm going to keep it as whole numbers as long as I can. Okay. The second one says negative 2.5, so that's going to be right here. And then plus negative 4.5, so my second addend is negative, so I'm moving left. For me, starting at negative 2.5, I'm going to move 1/2 first. And then I'm going to move 4 more. 1, 2, 3, 4. And that ends me at negative 7. Now I want to look at how to add rational numbers with different signs. So when we added integers with different signs, we subtracted and then kept the bigger sign. Kept the sign from the bigger number, I should say. That's pretty much what we're going to do. Except for a lot of the times we're going to use a number line here. So I guess that's another option. You could subtract them and then use the sign from the bigger one if you wanted to. Okay, but here we're going to look at this example. It says during the day, the temperature increased by 4.5 degrees, and at night the temperature decreased by 7.5 degrees, and we want to find the overall change. Okay, we don't know what it started at. We just know that that originally it increased 4.5 and then it decreased 7.5. So 4.5 is positive, 7.5 is negative. So I'm going to start at 4.5. And then I'm going to move left because this is negative 7.5. And again, for me, since I'm starting at a 0.5, I'm going to move 0.5 first. And then I'm going to move 7 more. Ending me at negative 3 degrees overall. Okay. So the temperature decreased by 3 degrees overall. The next problem talks about Ernesto writing a check. Maybe we say, maybe a better term for that nowadays is, let's say, used his debit card. For $2.5, or $2.50. Then he deposits $6 into his checking account. What is the overall increase or decrease in his account balance? So using money, okay, spending money is a negative, putting money into the account is a positive. So for this, we're going to start at negative 2.5, and we're going to move right 6. Now, how you want to do that, since we have a decimal and then a no decimal, is kind of up to you, right? You can just move to the gaps here, move 6 times. Okay, moving 6 times. That's one way to do it. Another way that some people like is to move to the 2, so I move 0.5. I know that I need to move another 0.5 somewhere, but I'm going to go as far as I can until I need to do that. So I'm going to move by ones now. So I'm going to move 1, 2, 3, 4, 5. And so now I've moved 5.5 and I have another 0.5 to move, and that other 0.5 takes me to $3.50. So a couple reflection questions. The first one, do negative 3 plus 2 and 2 plus negative 3 have the same sum? Well, this kind of takes us back to Module 1 a little bit. What did we do when we did this? You could either look at a number line, or you could just look at adding or subtracting. For this one, we'll look at a number line. I kind of like dealing with number lines. So let's go and put 0 in the middle, and I want to go to negative 3. I don't know why I didn't give myself a little more room there. Oh, geez. So you've got 0 there, 1, 2, 3. So there's my negative 3. And then I also have to get to 2. So first let's do, in red, negative 3 plus 2. So I'm going to start at negative 3. Move 2 times to the right, And then on the other hand, I'm going to start at positive 2 and move 3 times to the left. And I end up at the same thing. So do they have the same sum? Yes, they do. They're both negative 1. Okay. And so the question here is, does it matter if the negative number is the first addend or second addend? And the answer is no, it doesn't. The order doesn't matter. But notice what we did. 3 was negative in the first one. 3 is still negative in the second one. It's not that we just moved the negative to the other number, it's that we switched the entire numbers around, which is something you can do. Okay? Let's make a conjecture here. It says, do you think the sum of a negative number and a positive number will always be negative? Well, let's try some. A negative number and a positive number. Say negative 5 plus 3. Negative 5 plus 3 is negative 2. So that kind of fits the mold, right? I have a negative and a positive, and it is the sum is a negative. Can you think of one where the sum is not negative? Well, hopefully you can. Switch where the negative is. But leave the numbers the same. I'm going to say 5 plus negative 3. That equals positive 2. Okay? So, no. The short answer is no. What do I want to say to explain it, I guess? I'm just going to say it depends. On which number is larger. If the negative number is a bigger number, then the answer is going to be negative. If the positive number is a bigger number, then the answer is going to be positive. Okay? Some of these are a review from earlier, so we'll go through them a little bit quicker. Negative 8 plus 5. 1, 2, 3, 4, 5. Brings me to negative 3. I'm going to jump down and do this one because this one's also a review. Negative 1 plus 7. 2, 3, 4, 5, 6, 7. Brings me to positive 6. This one's the only one that's really new to this section. If I have 1/2, first I've got to figure out how my number line's configured. There's 1, 2, 3, 4 units to get to 1. So every one of them is 1/4. And it's important to know that 2/4 is 1/2. So I'm going to start at 1/2, and I'm going to move to the left 3/4. 1, 2, 3. Where is that? That is negative 1/4. Okay, now we've got a couple things that we've talked about before. We talked about the opposite before, and we always would say, like with subtraction, that we want to add the opposite. And really what that means is flip the negative sign. If it's a negative, make it a positive. If it's a positive, make it a negative. Okay, but here we're defining it as the additive inverse. It's a number that's the same distance away from 0 as the number we're looking at. So if we have negative 5, that's 5 units away from 0. Its opposite is on the other side of 0 and the same distance away. So that would be positive 5. Okay? And the trick here is that the sum of a number and its opposite, or its additive inverse, is always 0. And then the important part here is that 0 is always its own additive inverse, because it's 0 units away from 0. So you go 0 units the other way away from 0, and you're still at 0. Okay. We'll go through these ones pretty quick because they're pretty self-explanatory. A football team loses 3.5 yards on their first play and then gains 3.5 on their next play. Where do they end up? They end up right back where they started at 0. Okay? I don't even like this problem. Kendrick adds 3/4 of a cup of chicken stock to a pot. Then he takes 3/4 of a cup of chicken stock out of the pot. What's the overall increase or decrease? Well, if he takes out what he originally put in, then there's nothing. It's still at 0. Okay? So just getting us to see more examples of a number plus its opposite. And so we should see these ones pretty easily. We can show them on a number line. If I start at 2.5, and then I move left 2.5, move left a half, 1, 2, I end up at 0. So my answer there is 0. Negative 4.5, so I start at negative 4.5, or 4.5, and I move right 4.5, I move a half, or 0.5, and then 1, 2, 3, 4. And I end up at 0 again. It's amazing. Fascinating almost. All right, let's look at adding 3 or more rational numbers. So this is sort of taking it into like section 1.3 or 1.4, where we started like really getting more and more numbers involved. The only thing here is that we are dealing with rational numbers instead of integers. It does say, recall that the associative property of addition states that when you're adding more than 2 numbers, you can group any 2 of the numbers together. Okay, so here we're talking about, like, I have negative 5 plus 3. I don't want parentheses on that. So plus 3 plus 10. Maybe I want to deal with the 3 and the 10 first. Associative property says that I can do that. I can group the 3 and the 10, figure those out. Since it's all addition, I can do that. Okay, I can group those together, get 13, and then deal with 13 plus negative 5, or negative 5 plus 13. Okay? So in this example, it says that Tina spent $5.25 on craft supplies to make friendship bracelets. She made $3.75 on Monday, and on Tuesday, she sold an additional $4.50 worth of bracelets. Was her overall a profit or a loss? And what was it? Okay, profit means that when you take what you spent and what you made, when you combine those, that you end up with a positive. A loss means that would be a negative, that what she did wasn't worth it. So we want to use negative numbers to represent how much she spent and positive numbers to represent how much she earned. So she spent $5.25, and then she earned both $3.75 and $4.50. Group the numbers, so we want to use associative property here. We want to deal with our positives first. Okay, and when I do that, I end up with $8.25. Okay, and then what they do is they go ahead and look at finding the difference of the absolute values. So they go big minus little, and then and from that we get 3. So she earned a profit of $3. Let's look at how we can use that. Probably a good idea here again to go ahead and group our 2 positive numbers, deal with that first. So I have negative 1.5 plus 3.5 plus 2 is 5.5. And then I want to think about subtracting them. 5.5 minus 1.5, that's going to give me 4. And since the bigger number is positive, my answer is positive. Okay. This one might be worth to kind of think about rearranging a little bit. I'm going to move that -2 out in front. And then I'm going to have plus 3 1/4 plus -2 1/4. And I do that so that I can deal with these two first, because they both have 1/4. 3 1/4 plus a -2 1/4 is going to be equal to 1. So this problem comes down to -2 plus 1. -2 plus 1, you can think about subtracting them. You get 1, and since the 2 is the bigger number and it's negative, my answer is -1. A little bit of work there, but it's okay. This one I'm going to go ahead and add these first two together because they both have, there's one that has a 0.75, one with a 0.25, and I think they'll give me a nicer number doing those two together first. Since they're both negative, I'm going to add them and keep the sign. 2.75 plus 3.25 is 6, and I keep the negative sign. So -6 plus 5, that's going to be a -1. Lastly, these ones, it doesn't really matter which ones you want to do together. These two are positive, so there's a good reason to do those together. 15 plus 8 is 23, plus a -3. Think about subtracting them. I get 20, and since 23 is positive and bigger, my answer is positive. That'll be it for today. I know it was a long one, trust me, but I think we made pretty good work of it. Let me know if you have any questions. Write them down and ask them in class. That's the best way to be successful. Have a good day, and we will see you in class.